Hello everyone, welcome to Gangs of PCM. This is Priyanshu and together we are going to solve all your physics related worries. The question we are going to solve today is from JEE Mains exam held in January of 2020. This question is from chapter Magnetic Effect of Current, and to solve this question we need to know the concept of force on moving charged particle due to electric field and magnetic field. Now to solve the question we first need to draw the axes, x1 coordinate axes. So let's say we have these axes, let's name them. This is your x-axis, y-axis and z-axis. According to the question, we have a charged particle Q with mass m which is traveling in positive y direction at t equals to 0. Apart from this, we have two fields, two uniform fields. One is magnetic field given as B naught I cap and another is electric field given as E naught I cap. Now we would like to see the effect of both of these fields on this charged particle. Let's first look at the effect of magnetic field. Now, if this is your axis, let's say this is your y-axis and this is your z-axis. So using right hand thumb rule, you can find out the direction of the x-axis, which would be out of the plane. So the magnetic field would be out of the plane, which is along x-axis, positive direction of x-axis. So you have a charged particle at center, at origin, with velocity v0 and in presence of a magnetic field. So a charged particle is moving in presence of a magnetic field, so it would experience a force, magnetic force, and this magnetic force is given as Q V cross B, cross product of V and B. V is along y-axis and B is along positive x-axis. So if we do the cross product of that, we'll get a force along negative direction of z-axis. So this instant Fp is along negative direction of x-axis. The value of Fp would be given as minus Q Vb V naught B naught K cap. Okay, let's pay attention. So what would happen? See, due to this charged particle would perform uniform circular motion in YZ plane. As you can see from here, that at all instances, whatever is the velocity of the charged particle, whatever is the direction of velocity of the charged particle, your force, cross product of V and B, it would always be perpendicular to velocity and as well as your magnetic field. So it would always be in this direction, which is acting towards the center. Okay, so Fv would provide what? A centripetal force. So due to this, you will have a uniform circular motion. So what does it mean? It means magnetic field will do what? Your magnetic field would only change direction and no magnitude. That means it will not change the magnitude and it would only change direction. Now let's look at the effect of electric field. Effect of electric field. So if this is the charged particle Q, it would experience a force in the direction of electric field. That is the property of electric field. So your force Fe would be equals to Q E naught I cap. Now pay attention, this force would remain constant. That means both in direction as well as magnitude. Both of these quantities would remain constant. Why? Because force always acts in the direction of electric field, and if electric field is not changing, the force would not change, or direction of the force will not change. So this would change what? Electric field will change both direction as well as magnitude of velocity of charged particle. Okay, now if we see the effect of both electric field and magnetic field on charged particles simultaneously, what we'll experience? We'll see that, first name the axes. So we'll see that due to magnetic field, it is performing a circular motion uniform circular motion in YZ plane. So this is in YZ plane, and your electric field or this charge particle is also moving in the direction of electric field and magnetic field, and this effect is due to electric field. So this is due to electric field and this effect is due to magnetic field. So we can say your velocity have two components. One is V perpendicular and one is V parallel. So V perpendicular is perpendicular to both your electric field and magnetic field, and this is in YZ plane, and this would be what? V parallel is in direction of parallel to magnetic field and electric field. So this is along x-axis. Okay, so you can see V perpendicular would remain constant. Why? Why is this? Because this is effect is due to magnetic field and it does not change the magnitude of the velocity, it only changes the direction. So V perpendicular would remain constant, so V perpendicular would always be equals to V naught. We know this. Now what about V parallel? So V parallel is only changed by electric field. So this is only changed by electric field. So at any instant, initially you can say V parallel was 0. Yes, there was no velocity of the charge particle along x-axis. So initially this was 0. Now at any instant, your velocity can be given as V parallel can be given as 0 plus a along x-axis into time. Okay. Now acceleration, this is acceleration. So acceleration along x-axis would be given by electric field, and which would be how much? Q E naught, force divided by mass into time. So this would give you V parallel. Now if we find velocity at this instant, this would be what? V parallel square plus V perpendicular square. They both would be perpendicular to each other. So the resultant would be how much? Square of first and square of second. Same as this vector ax I cap plus ay j cap. Both of them are perpendicular. So the magnitude would be how much? Root of ax square plus ay square. Okay. So your V would be equals to V parallel is how much? Q square E naught square by m square into t square plus V naught square. Okay. This would be your velocity at any given amount of time or given any given instant of time. Now the question is saying we have to find time at which velocity is twice the initial velocity. So V is equals to 2V naught. If we square this equation, we'll get what? V square is equals to Q square E naught square upon m square t square plus V naught square. This will give you 4V naught square is equals to plus V naught square. Send this over here. You'll have 3V naught square is equals to Q square E naught square m square t square. So from here we get t square as 3V naught square m square divided by Q square upon or Q square into E naught square. Take the square root from here, you'll get t as root 3 V naught m divided by Q E naught. So this would give you the answer. At this time your velocity would become double of your initial velocity. Now see, the acceleration is due to electric field because only electric field would change the magnitude. Okay, keep this in mind. So if we look at our options, we'll see that your last option is correct. Option D is correct. With this, we are done with the question. See you guys next time. Thank you.